Yeah, yesterday, that'll be the first thing heard now. Yesterday, we we revisited long division, or not long division, we revisited synthetic division. Thank you, Albert. We revisited synthetic division and dividing any polynomial by a binomial. That's what synthetic division can be used for. And today we're going to be taking a look at how to narrow down our choices. So a couple of your homework questions, numbers 7 and 8, yes. Numbers 7 and 8 asked you to find the three factors. Now, of course, I designed 7 and 8 so that way they not only had three factors, but they were nice factors. But that's not always the case. And if I ask you what binomial goes into a polynomial, it could be anything. For all we know, it could be, you might have found out that the answer was -5/3. That was a solution, right? So we need a way to limit it because of the fact that we could literally choose any number. As a matter of fact, I had you guys do your number 9, I believe, said prove that x minus the square root of 6 was a factor of x to the 4th plus 36. Number 10. I got the question right. So minus 36? Yeah. Okay, minus 36. So, and you guys showed that it is. So even square roots are not out of the ballpark when it comes to deciding what to pick. So we have a couple of new tools at our disposal today. Now I've changed my note from what you printed out to something a little bit more appropriate, and I apologize for that. The front coefficient should not be p, it should be a sub naught. The front coefficient should be a sub naught, and the last term should be a sub n. This should be a sub naught, this should be a sub n. So change that, please, from your notes. Now I'm getting a little bit. I had to wait for like if I'm eating food with this, obviously I wouldn't be able to taste it. This is something I need to enjoy by itself. Yeah. Oh no. Soda's an anytime item for me. Next change. You guys are off topic here. A sub naught, that's just the first term. It's even before a sub 1. Okay? I'd like the side conversations to stop while she's just collecting. Albert, that's you. Nathan? Tylee? Right, because there are a lot of people not listening. We need to focus. I just asked you, unfortunately, right here, I don't have it on my tool to write on the screen. Give me a second. So right here, Destiny, I put P and I still don't have it there. Right here I put P and right here I put Q. Please change it to A sub naught in the beginning and A sub n. Because P and Q are actually something a little different. And I just mistyped that. So the rational root theorem, there's a big if. It's a conditional statement. All right? There's a big if. I even capitalized it. If a polynomial has rational roots. So this will not find the square root of 6. So an irrational root, if it has it, the rational root theorem will not work if the function has irrational roots. This is if it does have rational roots. Okay? And so it's in the form of, Destiny, this is just a long equation saying it's some polynomial. So it's some coefficient x to some power plus some coefficient x to 1 power less to 1 power less all the way till we run into just a number, right? If it has rational roots, they're in the form of q over p, where q represents factors of the last number and p represents factors of the first coefficient. Q represents factors of the last number and P represents factors of the leading coefficient. Okay, that's what it says right here. I changed that sentence just a smidge, so make sure you guys fix that as well. These can get long. Not hard, but long. And it's one of those times when, like, if I were to put two people together, person A and person B, how many different ways can they walk out that door? Two. Either person A goes first or person B goes first, right? If I were to put people A, B, and C, how many ways can they walk out that door? 6. A, then B, then C, or A, then C, then B, or B, then A, then C, or B, then C, then A, or C, then A, then B, or C, then B, then A. Yeah. So we remember that, right? It can get big fast, right? And if I do 4, I don't even want to talk about the 24 different possibilities. So here, guys, we're taking all factors of A sub naught and all factors of A sub n, which means if there are a lot of them, we might end up with a bunch of combinations. The hard part, quote unquote, will be making sure we don't miss any. And as long as you develop a pattern, you're not just like randomly choosing numbers, you won't miss any, as long as you go in a pattern. Okay? So the easiest thing here is to actually do an example. So don't forget there's a little bit of writing here, right? So actually let me copy it over. I'm going to steal it over. You will. Why? All right, and then but that's your turn. Oh, I haven't given you the new page yet. Yeah. There's more to it. I just didn't pass it out. My apologies. Yes. Yeah, I've got a bunch of them right there. Okay, so Anthony, what is A sub naught in this example? Just 4. The x is not A sub naught. Okay, A sub naught is whatever coefficient's in front. So A sub naught is 4. Is everybody all right with that? Okay. What is A sub n, Lucas? We don't care about the sign? Just 25. Yeah, I've got loaner pencils. If there are none back there, there's some in this like middle drawer. Okay? So A sub n is 25. And we're going to get why I don't care about the sign in just a second. Taking it nice and slow. Everybody okay? Sarah, you feel all right with that? So now we have to define P and Q. P is every factor of A sub naught. Every factor of A sub naught. So P. And here, since we're talking about factors, it means what can multiply to get 4. Which means every single one of our factors has a plus or minus in front of it. Yep. Plus or minus 1, 2, 4. We don't need to put plus or minus in front of every single one. Did I do this in Algebra 2? Yes. Okay, we did. Cool. All right, then. It's still review, which means our quiz coming up will be nice and easy. Okay?
When is it? Is it like this week?
Yeah. This is the last section of before a quiz. We do 4 sections.
Wait, what's the next?
Thursday. All right.
Thursday?
Yes. Sarcasm much? Nope. Okay. We good?
No.
Quiz.
Why is it 1, 2?
So it's all factors of 4. P is factors of A sub naught. What multiplies to get 4? Either 1 times 4 or 2 times 2. So we're just picking factors of 4. Yeah. A sub n is 25. It's whatever the last number at the end is. And as long as it's in descending order, it's the number at the end. Okay? So, and I'm not overall going to try to fool you by like misordering it or something like that. Okay? So A sub n is a little easier, which is our Q values are factors of A sub n. So it's a plus or minus in front. And what multiplies to 25?
1, 5, 25.
Yes, strange children. It's really hard to copy someone when you do it completely synchronously. So now, here's the part where you guys can miss a step. and you've got to be careful. We do every possible version of Q divided by P. As long as you keep an order, you won't miss any. So every possible combination of Q divided by P. These are all going to have a plus or minus in front of them. So pick a Q. 1. We just pick the first. We just go in order. If you want to pick the middle one, that's fine, but we want to keep an order going. Okay? So 1 over 1, 1 over 2, 1 over 4. Because it's the Q's over the P's. 1 over 1, 1 over 2, 1 over 4. Then we just move on and pick the next Q, which is 5. So we're going to do 5 over 1, 5 over 2, 5 over 4. Then we pick the last Q. And this is where it can get long. Right. So now, if you guys are okay understanding that 5 over 1 is 5, great. If you need to rewrite the list so all the over 1s turn into just a solid number, then rewrite the list. If you need to go through and reduce any fractions, then go through and reduce any fractions. This has no fractions. The only thing I could possibly, and you also should go through and then scratch out duplicates. So quite often, if you write every combination down, you're going to end up writing it again just with a simplified version. Right? So I'm going to go ahead and do that just so we can get the process down, even though it's not going to reduce the size of my list this time. And if you don't want to, because you're like, this is redundant, I really don't need to, 1 divided by 1 is 1. 1/2 doesn't reduce. 1/4 doesn't reduce. 5 over 1 is 5. 5 over 2 doesn't reduce. 5 over 4 doesn't reduce. 25 over 1 is 25. 25 over 2 doesn't reduce. And 25 over 4 doesn't reduce. So this did not shorten my list. There were no duplicates. There were no duplicates and nothing reduced except for the over 1s. So these are my options. When I do the synthetic division and I make a little box, instead of saying I could pick anything, no, I can pick these 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 numbers. I can pick, it's done. I'm not going to do synthetic division now. It just says find the possible rational roots. The plus or minus makes there 18 possible combinations. Yes, it sucks, but don't forget that once you find one of them, and as you guys get better, this is something I even said in Algebra 2, as you guys get better at synthetic division, you'll be able to start going and then be like, nope, that's not going to work. You know, you won't even make it to the end of it before you realize that a number is not going to work out right. Oh yeah, well that's if you erase a lot. You can just cross and get a new sheet. So, we okay? Any questions about this? So the next thing is, what do I have on there? Descartes. No, it's Descartes, right? René Descartes. So we have our French mathematician, René Descartes. And he has Descartes' rule of signs. So Descartes' rule of signs, if you don't recall from Algebra 2, Descartes' rule of signs, we take the function, and every time the sign changes, if we take the function f of x, and every time the sign changes, that means there could be a positive rational root. There could be a positive rational root. I'll read his rule of signs in just a moment. Let me just hole punch for you guys. Where were you at there, Victoria? In another world. I did not. Sorry, I had a very busy afternoon. Woo!
Ooh, good one.
Yes, this speaker is much closer.
Hi, Mom.
Does your mom watch these videos? Oh, so well, they're here for you. All right. I have before once. I like that phrase. Okay. So Descartes' rule of signs. The number of positive real zeros in a polynomial function f of x is the same or less than by an even number as the number of changes in the sign of the coefficients. Whew. Crazy words. Likewise, the number of negative real roots in a polynomial function f of negative x is the same or less than by an even number as the number of changes in the sign of the coefficients. So we've got an example. Use Descartes' rule of signs to determine the number of positive or negative real zeros from the example above. So, in the example above, so let's go ahead and rewrite the function at the bottom of the page. Let me actually, here we go. Let me clip this. Does anybody think they remember exactly how to do this? And by the way, my out-of-state students, have you guys gone over this before?
Yeah.
Out-of-state students. You're not out-of-state, Jada.
Yeah.
Yeah? Leo? No?
No, but I think I can get it.
All right. Lucas, you've gone over this? No? Okay. So this is Descartes' rule of signs. So we've got the function f of x, correct? We good? What's the sign on the front, on the leading coefficient? Positive. Did I change? Yes. It went from positive to negative. So I put a little 1 underneath it. This is just a graphical way to represent it. I changed signs, so I put a 1. Did I change signs? Yes, I put a 1. Did I change signs? Yep, put a 1. Did I change signs? Yep. Did I change signs? Yep. So I changed every time. If I didn't change signs, I would put a 0. Okay? From the previous term, yes. So I went positive, negative, positive, negative, positive, negative. I changed signs every time. So I put a little 1 every time I changed signs. So what this means, by Descartes' rule of signs, I could have up to 5 positive roots. Positive real roots. Positive real roots. What? 5. And now read the next part of that line when I read that Descartes' rule of signs. Or less than by an even number. Right? So what's our first even number? That's not our first even number.
0.
2 if I count my evens. 2 is my first even number I count by. I'm just saying by an even number. I'm not talking about in this function. My first even number period is 2. So what's 2 less than 5? 3. What's 4 less than 5? So I have 5, 3, or 1, because I can't have a negative amount of real positive roots. I have 5, 3, or 1 positive real roots. Just keep subtracting by 2 until you hit 1 or 0. Keep subtracting by 2 until you hit 1 or 0. How many negative real roots do I have? Right? So to find how many negative real roots, I put in f of negative x. Now remember, f of negative x, when dealing with a polynomial, if I substitute f of negative x, only the odd exponents change signs. Only the coefficients with an odd exponent change signs. So, I'm going to write down what is f of negative x. Is the first exponent odd? Is the first exponent odd? Yes. 5 is odd. Exponent, Jada, not coefficient. The first exponent is odd, so therefore the first term changes signs. This is even.
So he's redoing the first one.
It says, so if you look here, if you guys look,
I'm writing it.
no, you're fine. It says use Descartes' rule of signs
And you just
from the example
answered
above.
that.
Yeah,
Okay.
from the example above.
Yeah, I was confused. Yeah, at first I didn't want to say anything.
Right. You're fine. Negative 2x to the fourth, that's an even exponent, so it doesn't change signs. 30x cubed, that's an odd exponent, it changes signs. Negative 15x squared, even exponent, doesn't change signs. 50x, odd exponent, changes signs. Negative 25, no exponent, can't change signs. So, did I change signs?
No. Oh.
Did I change signs?
No.
Did I change signs? Did I change signs? Did I change signs? So this has no negative real roots.
So if the first exponent is odd, just change all the.
As long as I don't skip one. What if I skipped? What if I didn't have an x to the fourth term?
Then it's 0x. Oh, so as long as it's even, you
Don't change even exponents. Don't change the sign of the coefficient of even exponents. I have to be, as I do these videos, I'm trying to be a little bit more technical, a little less colloquial when I'm teaching you guys, because I need to make sure my vernacular is appropriate. Yes?
So when the exponents are 1, they still don't change the sign?
They do. It's odd. Because that's 50x to the 1, so that's an odd exponent. So positive 50 changes to negative 50. Some people make a little chart with this. Some people make a little chart. So this would be it when I'm saying determine the number of positive real roots and negative real roots. This would be the solution. On the next problem, we're going to create a little chart to show how it all comes together. So earlier, Aiden made a face when I said there are up to 18 possibilities for our roots. But if we use Descartes' rule of signs really quick, none of the negatives will work. So we're down to 9. But and also a bonus to the positive real roots, we know there are 5, 3, or 1. So there is at least one. One of those will for sure work by Descartes' rule of signs, because there's not an option for 0. Right? Either one of them will work, 3 of them will work. So if you find 2, there's going to be a third one. If you find 4, there's going to be a 5th one. It kind of helps us narrow down when we should stop looking. And we've got something in the next section, which we're not going to worry about today or tomorrow. We got something in the next section that helps us know when to stop looking. Yeah.
For the homework, do we have to find like the actual factors of this?
Yep. Okay. So for our example, we're going to combine the rational root theorem and Descartes' rule of signs to find the zeros of this function. So I gave you guys lots of room, but still may want to kind of write compactly. So let's start off by the rational root theorem. What is my a sub naught, Sarah? What is my a sub n, Victoria? Okay. Jada, what are my so my p is going to be factors of 3. What are my factors of 3, Jada? 1 and 3. My q is factors of 5. What are my factors of 5? Aaron? 1 and 5. Some of your p's and q's will be easy in this homework, and some of them will be longer. I mean, I'm not trying to bombard you with murder here. Okay? Q over P. My apologies. Q's over P's. So so take the first possibility for Q is 1 over 1, 1 over 3. 5 over 1, 5 over 3. So right now we've got 8 possibilities. I'll do a quick reduction. All right. So there's rational root theorem at work. Any questions on rational root theorem? Tyler, you feeling this one? Okay. So now we're going to use Descartes' rule of signs. Did I change? Yes. Did I change? Did I change? Did I change? Oop. Ha. 1. So I've got positive 3x to the fourth, then negative 10x cubed. I changed from a positive to a negative. Then I changed from a negative to a negative. That's not a change. Negative to a negative. That's not a change. Negative to a positive. That's a change. So adding those, my number of positive real roots are 2 or 0. Because it's 2, or subtract 2 as much as I can until I hit 0 or 1. Then I've got to use f of negative x. I'm going to pause because I think I might be going a little fast for some people. Lucas, I'm going to want you to tell me what f of negative x is.
F of negative x is...
Think about it for a second. I'm giving people a chance to write before I write. Don't die, Albert.
Off-topic question. So I already found one of them. So if I'm trying to find another one, can I pick up from here, or do I?
All right, Lucas, what's f of negative x? Ooh, no, positive 3x to the fourth. Why, Lucas? Even exponents. Even exponents don't change. So then, positive 10x cubed. Uh-huh. Okay. Didn't change. Did change. Did change. Didn't change. So number of negative real roots is also 2 or 0. Now we're to our guessing game. Now we're going to do synthetic division, and we're going to try to find our roots. This could have only imaginary roots. It might be that none of my 4 possible P over Q's work, or Q over P's. It could be possible that none of my Q over P's work because of the fact that I have a possibility of 0 positives and 0 negatives. It could be they're all imaginary. Then life just sucks and you had to go through 8 different attempts without finding anything. Yeah, so we're going to try them all. So now it's our guessing game. However much you want to erase Albert's up to you. So let's make a smart pick to begin with. So let's get our roots. We want to try 1. And what are our coefficients? Oh, there. Oh, be careful, by the way, because quite often the last step you'll have done before you start your synthetic division is you'll have written what f of negative x is. Don't use those coefficients. Use them from your original polynomial. There's a lot of times I've caught myself using these coefficients on accident. So my coefficients were 3, negative 10, negative 24, negative 6, 5. Sada wants to use 1. Sada wants to use 1, so that's what we're going to try. I'll give you guys a second. No, if you guys just want to hold off on writing and we'll try it as a class, or you can write the example down, okay? I mean, this is going to be written in your notes no matter what, just not what's in that little box right now. We're trying to find the possible roots of this polynomial.
How do we know if we get roots?
Because we'll get no remainder. Remember yesterday's homework? If we have no remainder, then it's a root. Well, yeah, but we've limited our guessing to... Switch your number, sure. What do you want to switch it to? Negative. Well, you can just add a negative in front of it, Tylee. All right. All right, all right. So, guys, we know the algorithm. Multiply, add, multiply, add, multiply, add, multiply. Works out. So we have no remainder. So we found our first one. Now, is that a positive or negative number? So that means for sure there's one more negative number. So we should try a negative next. And are we going to use these coefficients again? No. Which ones are we going to use? We're going to use the depressed polynomial. Mr. Richard, you okay? You've never heard that phrase? It's not a thing.
Wait, Mr. Mix, can't we just go backwards?
What do you mean?
Like put a 0 right here and then go like up. Like -5. Like do everything backwards. Then you could get it like.
I don't think so.
Why?
Possible, but you'd have to show me what you mean a little later.
Okay.
Okay. So let's find our other negative number. So we're going to use these coefficients, 3, -13, -11, 5. So find our other negative. Is it going to be -1/3, -5, or -5/3? Don't avoid the fractions just because you don't like them. Destiny. So what's happening is, what's kind of happening in behind, why we can use the depressed polynomial, why we can use that quotient. So Destiny, if I were to ask you, let's just go back to arithmetic and use just solid numbers, right? Yeah. I want you to pick a number that goes into 48. 6. So if I divide 48 by 6, what do I get? 8. Okay? I get 8, right? So now that I've got 8 and I want to figure out what else goes into 48. Well, what goes into 8? 4. Does the fact that I'm using 8, does that mean 4 doesn't go into 48? No. So I can use the smaller number. It's okay. It makes my life easier because I know it goes into 8 easier than when I know it goes into 48. So let's pick a negative number. -5? -5/3? We have an argument. You want 5/3 also? Okay, no, you both want -5/3. Okay. So guys, you can stop on fractions if the fraction never goes away or at some point doesn't go away. Stop the fraction. It'll usually mean it doesn't work. If the fraction doesn't go away after one of the multiplications, stop the fraction. Okay? -5/3 times 3 is what? -5. Add those, -18. Does 18 divide by 3? Yes, so I can keep going. If it didn't, if I got a number here that doesn't divide by 3, done. Because my fraction will just get worse as I go. Okay? So, -5/3 times -18. Well, 18 divided by 3 is 6. 6 times 5? 30. So we get 30. 30 minus 11. Doesn't work. 19 is not divisible by 3. Okay, I'm holding up. Did I do something wrong? We got to get it to 0, but since that's 19, 19 doesn't divide by 3, I can't cancel that +5. You think you're a genius? I don't know what you mean by that, Victoria. Okay, okay, I see what you, okay, that's what you meant. Negative 5. So what, but what would have, I don't know what number would have to be, a lot of things multiply to negative 5. What in particular? Yes, you're right. This part, Victoria, and this part can always be filled out because you know what you want it to be. So let's pick negative 1/3. No? I don't know, I'm just trying. That's going to make negative 1. Nope, doesn't work because that makes negative 14. So negative 5 makes negative 15. That no way it can work. Well, we have to have a second negative answer. We have to have a second negative solution. Why didn't it work then?
Because I didn't start out with the number. I started out with 5 with negative 1/3 and then negative 5/3.
So unless my math was wrong, it should work no matter what step you bring it into, though, Indigo. So unless I did something wrong, which I might have, maybe I'll go back and I'll realize it. That's still 30. Yeah. That's still 30. So but negative 5/3 times 3 is negative 5. Negative 5/3 times 3 is negative 5. So there's a chance, right? So I've tried negative 5. It didn't work. You guys okay with that? I tried negative 5/3. It didn't work. You guys okay with that? I tried negative 1/3. It didn't work. You guys okay with that? I never said you can't use the number twice. Destiny? Destiny, we'll come back to your no question in a second. So, yeah. We'll go back to that. We'll come back to this in a moment. So, Destiny, let's go back to the easier question a second ago, right? What, if I were to say, I want you to factor 8. I don't go with 48, okay? I want a smaller number, right? What multiplies to 8? 1, 2, 4, and 8. So let's do a little factor tree on it. So let's not use 1 and 8. So let's use 2 and 4. But 4 factors. And so you can have a duplicate factor. So it's okay to use the same number again. That might not always happen, but I wanted you guys to see that it could happen. It could happen. You can get a duplicate factor.
So the number that we're using in this synthetic division,
it has to be. Descartes' rule of signs said that I had 2 or 0 negative roots. It wasn't 0 because one of them worked, which means I have to have 2 negative roots. Try a duplicate. You can try the duplicate earlier than that if you'd like. You don't. There's no way to know. Who's to say I didn't do this next no matter what?
Okay, so why didn't we use synthetic division twice?
We keep doing it until we find them all.
So if no other number works, it's just gonna be the same number over again?
Could be. Try it. Otherwise, you might find you did something wrong. Yes. So, no, we're almost there. We're down to this. So now we're done with negative roots. There could only be 2. So now they're either 0 or 2 positive roots. So we got to try a positive number. 5.
15.
Okay. 15. Negative 1. Negative 5. So 5. So that means we definitely for sure have another positive root. Now, guys, I'm going to give you a little tip here. I'm going to give you a little tip. I'm not going to create a synthetic division for 3, negative 1. Now, if you guys don't get this, then you can go back to using synthetic division again for 3, negative 1, but you don't have to. What was the original exponent on my polynomial? x to the fourth. So these coefficients represent x to the fourth. Are we okay with that? Therefore, these represent what? X to the third. These represent x squared, and these are x. So we have 3x minus 1 equals 0. X has to be 1/3. The last one, we can just set it equal to 0 and solve. The last one, we can simply set equal to 0 and solve.
Why is it 3x?
Because I've dropped a power every time.
So the first long division is going to be.
This was x to the fourth. Let me answer Satter first. This is x cubed. This is x squared. And now this will just be x. Okay? So, Aaron, what was your question? Okay. Right. So, our solutions, therefore, are x equals -1, x equals 5, and x equals 1/3. Since -1 occurred twice, we simply add the words in multiplicity 2. That's saying, so in other words, if you get something and it happens 4 times, you can just say multiplicity 4, multiplicity, however many times it occurs, that's the multiplicity.
When do you know when you just use the number twice?
You keep trying until, yeah, keep trying them.
That's configuring.
So do you want to start it like that? Because I wrote it like in the factor version.
It says, what are the zeros? So the question meaning, what are the zeros? If it said, what are the factors? That would be correct. If the question said, what are the factors are x plus 1 times x minus 5 times x minus 1/3, right? Those are the factors. If it asks for what are the zeros, it means what x value will zero this out. X equals -1, x equals 5, x equals 1/3.
So you should just give us like a hint on the text. Like the factors are 1 through 5.
There are only 6 problems here.
No, I mean like on the test.
Oh. So guys, you have 6 minutes to go ahead. This is it. This is the whole lesson. Last night's homework was done pretty quick if you guys watched the video.